Hello everyone and welcome back. Now today we are going to learn two very important topic on linear algebra, which is null space and range space. So null space का जो another name है वो है kernel of T और जो range space है उसे हम लोग range of T भी बोल सकते हैं. Now for null space, first you have to take two vector spaces U and V. Okay, U and V are two vector spaces over the same field F. And after that we have to take a transformation, linear transformation. So I think you have gone through this in our last lecture. We learned what is linear transformation. So T is a linear transformation from U to V. So for the condition of linear transformation, what is the rule? T of alpha x plus beta y should be equals to what? Alpha into T of x plus beta into T of y. So if this particular condition satisfies by T, then you say that T is a linear transformation from what? U to V. Okay, so T is a linear transformation. And then the null space or kernel of T. So null space or kernel of T क्या है? Is defined by the set of all vectors in U whose images under T is what? Zero element of V. So this is very important. So null space क्या है? In null space we have some elements of U. So indirectly null space is nothing but a subset of U. So null space में क्या रहेगा? Those elements of U whose images are zero element of what? V. Okay. So let us try to understand by drawing a diagram. This is U and this is suppose V, two vector space, and T is a transformation from U to V. So U is a vector space. So vector space में क्या रहता है? Zero element. और capital V का जो suppose zero element है, वो zero dash. Okay. So other than this, there are some other elements. So suppose x1, then x2, x3, x4, like this. There are so many elements. Suppose x1 का जो image है, यहाँ पे भी suppose y1, y2, then y3. There will be so many elements. y5. So हमें देखना है for what element of U have the image zero dash in V. यहाँ पे लिखा हुआ है zero element of V. So zero element of V मतलब zero dash. So suppose for example x1 का image हम लोग मान लेते हैं 0 बार है. Then जो 0 बार है ना, there is a condition that T of 0 बार का जो image है वो क्या होगा? हमेशा zero dash ही होगा. तो minimum एक तो element है ही. So the image of 0 bar is what? 0 dash. And suppose x4 has also this, and these elements x2 has some other images. These are some other images. So this is a function, also linear transformation. Now what is n of t? So जो null space है, that null space is denoted by what? N of t. Okay, null space of t. So what is the definition? In null space we'll get some elements of U whose images are what? 0 of V. So यहाँ पे कौन सा element का जो image है वो 0 है? x1 and then 0 bar and then x4. Okay, because all these elements have image what? 0. So this is called null space. So in general, how will write null space? See, null space. In null space we'll get some elements of U. U का element रहेगा such that T of x, उसका जो image है, that will be what? 0 dash. What is 0 dash? 0 dash is 0 element of V. Okay, so it's very simple. Null space is a set, or you can say null space is a subset of U. Inside this, what elements will there? All those elements of U whose images are what? 0 dash. Now there is one theorem where you can show that null space is a subspace. Okay, show that. There is one theorem. Show that n of t is a subspace of what? U, because n of t is a subset of, see, the elements of n of t are all lies in U, so it will be a subspace of U. Now what is the condition for subspace? So we have a W is a subspace of V. There is one definition, right? W is a subspace of V when if alpha x plus beta y belongs to what? W. For all x comma y belongs to W and alpha beta belongs to what? Field. So the same definition will apply here. Okay. So what to show? We have to show that n of t is a subspace. तो सबस्पेस दिखाने के लिए, so what is n of t? n of t में क्या रहेगा? n of t consists of those elements of U whose images are what? 0 dash. 0 dash means what? 0 element of what? V. ठीक है? So here what is t? T is a function. T is a linear transformation from U to V. Okay? U to V. So to show that this is a subspace, हमें क्या करना है? We have to take two elements. Let x comma y belongs to n of t, and दो स्केलर लेना है. Alpha comma beta belongs to what? V. It is very simple. Take two elements from n of t and two elements from the field. Sorry, from field. Now why x and y belongs to n of t? x और y ये n of t में क्यों रहेगा? Because कौन सा एलिमेंट n of t में रहता है? Whose images are what? 0 dash. You see this condition. Now if x belongs to n of t, that is t of x will be 0 dash. Similarly y भी n of t में, that means t of y equals to how much? 0 dash. Now alpha x plus beta y, इसका ट्रांसफॉर्मेशन निकालना है. ओके, t of alpha x plus beta y. So t is already transformation. Okay, definition में t is a transformation. So transformation condition क्या था? What is the condition for linear transformation? If t of alpha x plus beta y can be expressed like this: t of alpha x plus beta into t of y. Now alpha into t of x, just now we have, it's 0 dash, beta into what? 0 dash. So alpha into 0 dash plus beta into 0 dash is again how much? 0 dash. Now it's very interesting. You see, t of something, alpha x plus beta y, this is an element, right? t of something equals to 0 dash. So यहाँ पे क्या दिया हुआ है? अगर किसी एलिमेंट का इमेज, ओके, अगर किसी एलिमेंट का इमेज 0 dash है, then that particular x will come in which set? That x will come in n of t. Now here t of something is equals to 0 dash. So therefore alpha x plus beta y belongs to what? N of t. Okay. Now see, if alpha x plus beta y belongs to W, then what? W is a subspace. Okay, W is a subspace. So here also, since alpha x plus beta y belongs to n of t, for all x comma y belongs to n of t. So if this condition satisfies, then you can say that n of t is a what? Subspace. This is a very simple proof. Okay, it is a subspace of what? U. Okay, now let us go to the range space. What is a range space or range of t? So similar type of definition. So U and V are two vector spaces. Again, t is a transformation from U to V. Then now see, image set. Okay, the image set under image set of U under V is called range of t. So let us try to understand by drawing a diagram. These are the two different vector spaces. T is a transformation, x1, x2, x3, x4. Okay, so यहाँ पे भी 0 एलिमेंट है. So हम लोग यहाँ पे शो नहीं किया है. So suppose x1 का जो इमेज है वो y1 है. Suppose x2 का इमेज y1 है. x3 suppose y2. And this is suppose y3. And there are some other elements also. Okay, there are some other elements. Now see, elements of U. Okay, the elements of U, उसका जो image है, those images are in V. So let us make a set with the images. So what are the images? Y1, y2 and y3. So these are all images of some elements of U. So the set of all images, see, set of all images of U under V is called range of t. So this is range of t and it is denoted by R of t. So here see, R of t is a subspace of what? V. But in null space, see, null space में क्या था? Null space n of t is a subspace of U. Okay, null space is a subspace subset of U. So null space lies under U, but the range space will be inside what? V. ओके, इज इट क्लियर? सो इट इज डिनोटेड बाय आर ऑफ टी. सो आर ऑफ टी में क्या रहेगा? आर ऑफ टी में क्या रहेगा? दोज एलिमेंट्स ऑफ v. So suppose y1 y2 y3, so those elements of v, so हम लोग y को ऐसे भी लिख सकते हैं, सपोज d of x such that this x कहाँ पे था? इसका जो प्रीमेज है वो कहाँ पे रहेगा? u में रहेगा. ओके, सो range of t consist of some element of v whose preimages are in what? u. So you can show that range space is also a what? Subspace. Show that range of t or range space is a subspace of V. Okay, proof. So for that, let us define what is R of t. So in R of t, what type of element will be there? T of x. Because you see, if this is u, this is v, and the function is t. So if we take element x here, इसका जो image है वो कैसे लिखते हैं? T of x. Okay, T of x. So what kind of element will be there? T of x, such that जो x था वो कहाँ पे था? Belongs to u. Okay, this is the definition of range space. So what to show? We have to show that R of t or range space is a subspace. So again the same definition. To show that it is a subspace, we have to take two elements from, sorry, T of x and T of y. Let us take two elements from T of x comma T of y belongs to R of t. Let us take two elements from R of t. So then what does it mean? If T of x and T of y belongs to R of t, it means x and y are from u. And we have to take two scalar, alpha comma beta belongs to what? F. Suppose the scalar field is F here. So now, now T of x, or better we can write like this, y1 comma y2. If we take y1 comma y2, then T of alpha x plus T of alpha y. Okay, so we can write like this also. Let y1 comma y2 belongs to what? R of t. Okay, that part we will write later. Now see, we have taken two elements from R of t and two elements from what? Field. Now see, y1 and y2 belongs to R of t. What does it mean? So that means y1 has a preimage in u and y2 has also a preimage in u, because you see T of x. Suppose ये जो element है, तो मान लीजिए this element is y. So if y belongs to R of t, then y का जो preimage है वो कहाँ पे रहेगा? u पे रहेगा. So then there exists x1 comma x2 belongs to what? U, such that T of x1 will be equals to y1 and T of x2 is equals to what? y2. Okay, so y1 का जो प्रीइमेज है वो x1 है और y2 का जो प्रीइमेज है वो क्या है? x2. And we have taken two scalar, what? Alpha and beta. So therefore alpha x1 plus beta y1 ये कहाँ पे रहेगा? Sorry, alpha x1 plus beta x2. So this particular element will belongs to where? See, x1 and x2 are images. Sorry, x1 and x2 are element of what? U. What is U? U is a vector space. So if U is a vector space, then alpha x1 plus beta x2 belongs to what? U. So this implies अगर ये element U का element है, so इसका जो image है वो कहाँ पे रहेगा? T of x1 plus T of alpha x1 plus beta x2 ये कहाँ पे रहेगा? This will belongs to what? Range of T. Okay, this particular element will belongs to range of T. So this implies, what does it mean? Or we can better write alpha x1 plus beta x2 is from what? Which set? U ना. So इसका जो image होगा, image रहेगा range पे. So इसको define मतलब तोड़ने से क्या आएगा? So this will be equals to alpha into t of x1, yes, plus beta into t of x2 belongs to what? R of t. Now why you can break like this? Because t is a linear transformation. T is linear transformation. This is the definition of linear transformation. So this is equals to, this implies alpha into, what is t of x1? You see, t of x1 is y1. T of x1 is y1. Similarly, beta into y2. So belongs to what? R of t. Now see, we have taken two element y1 and y2, right? y1 and y2 belongs to R of t. तो subspace दिखाने के लिए क्या करना होता है? We have to take two element and two scalars. And if we can show that alpha y1 plus beta y2 belongs to R of t, then it is a subspace. Now see, the same element we got here. So alpha y1 plus beta y2 belongs to R of t. So what does it mean? R of t is a subspace of what? Subspace of V, क्योंकि R of t V का subset होता है. So okay, so it's very simple, it's not that much tough. Okay, so I hope range space and null space are clear to both of you. So kindly go through it, but because before learning null space and range space, kindly finish linear transformation. Otherwise, you have a little less idea in linear transformation. So if you gone through linear transformation first, and then the definition of nullity and range space will be very much clear to all of you. So in our next lecture, what we will learn what is nullity and range. So that is again one very important topic where the problems are generally coming to in all the exams. So thank you for watching the video till now. So if you like the video, kindly share with your friends. Thank you for watching.